Hi everyone, I'm De Caro Federico, Product Manager Data Center Specialist, and today we are going to take a look at free cooling solution for data centers. What is free cooling and why it is used in data centers? Free cooling is a technology that leverages outside air with heat cooler than an indoor environment, thereby reducing the overall cost of cooling the data center itself. However, there are different ways to implement free cooling, and today we will analyze them: direct free cooling, indirect air free cooling, and indirect water free cooling. Let's also start from the typical configuration of data center, which includes the installation of perimeter units that can operate with direct expansion or with chilled water. In this case, the solution offered by HiRef is to integrate a free cooling module installed directly on the unit. This free cooling module, equipped with multiple dampers, allows operation in three different modes. Mechanical cooling, when the outside air is too warm and free cooling is not available. Thus cooling the data center either through the compressor or the chiller water coil, depending on the technology used by perimeter unit. Total free cooling, when the outside air is cool enough to cover the entire load, or free cooling plus mechanical cooling, when outside air only partially contributes and the rest is provided by mechanical cooling. What are the advantages of this solution? The advantage is that I can exploit many hours per year of free cooling operation. On the other hand, there is a risk in introducing outside air that is dirty, dusty, or even aggressive. In addition, with this mode, we don't have precise control of the room's humidity, and therefore humidifiers or dehumidifiers are required. Now let's analyze air indirect free cooling. Free cooling is called air indirect when the outside air doesn't not directly enter the data center, but cools an airflow through plate heat exchangers, thus avoiding any mixing between indoor and outdoor air. For indirect free cooling, perimeter units are combined with heat recovery systems with cross-flow heat exchangers that enable thermal exchange with outside air. The air inside the data center cools down by transferring heat to the outside air without mixing. The pros of this solution are that we don't have the intake of so-called dirty air from outside, and therefore we can have precise control of the indoor humidity in the room, which cannot achieve with direct free cooling. On the downside, the intermediate heat exchangers implies a reduction in the operating hours in free cooling mode compared to direct free cooling. In addition, with this solution, we have another drawback, which is the need to install additional fans to handle the external airflow, resulting in higher energy consumption. An improvement, let's say, of the indirect free cooling system is the adoption of evaporative cooling. An example are adiabatic units by HiRef, which use indirect free cooling with evaporative cooling through a cross-flow heat exchanger combined with an adiabatic system that pre-cools the outside air, increasing the efficiency of the exchange. The system therefore operates in three modes: indirect free cooling, that is only the heat exchangers, similar to the solution analyzed previously. Free cooling plus adiabatic cooling, that is when the outside air is not cold enough to guarantee free cooling mechanically alone, so it's necessary to spray water into the airflow. Or the last mode is mechanical cooling combined with adiabatic. In this way, the airflow that exchanges with the condenser is sprayed with this atomized water, which reduces the condensation temperature at which the unit operates, thereby increasing the efficiency of the system itself. The pros, also in this case, are that we don't have any intake of dirty air from outside. We have an increase in free cooling hours thanks to adiabatic cooling, and we have precise control of the humidity inside the room. The drawback is that we have water consumption, and it is an optimal solution only where water is scarce, because it is perfectly for dry climates. This system also requires more frequent maintenance in order to ensure the correct operation of the unit. Let's now move on the free cooling mode defined as indirect water-based. HiRef offers several solutions that use indirect water-based free cooling. The first solution we are going to analyze are the perimeter free cooling units combined with the dry cooler. HiRef perimeter free cooling units are equipped with a double coil, one direct expansion and one water-cooled, connected to an external dry cooler. Direct free cooling is activated when the return water temperature from the dry cooler is cooler than the indoor air by certain delta T. If instead the outside temperature is not low enough to meet the load, the remaining portion is covered by the compressor. What are the pros and the cons of this solution? Also in this case, there is no mixing between indoor and outdoor air, so there is no intake of dirty air. We have precise control of humidity inside the room, but the drawback is a reduction in free cooling operating hours compared to direct free cooling. HiRef also makes it possible to take advantage of indirect water-based free cooling with solution featuring water-to-water chillers combined with the PLM module. In this way, with the PLM module, we are able to use, as in the previous cases, 3 operating modes. Mechanical operation, where cooling is provided by the compressor and the heat dissipation is handled by dry cooler. The total free cooling operation, where the heat of the data center is dissipated through the external dry cooler, or a hybrid mode which pre-cools the water supplying the parameter units of the data center with dry cooler, and the remaining portion is supplemented with the mechanical cooling of the chiller. The standard free cooling chiller is equipped with the free cooling heat exchanger coils, where the plant water exchanges directly with the outside air. The standard free cooling chiller requires that the system water be glycolated in order to protect it during the winter season, in case of unit shutdown, since if the temperature were extremely low, ice could form inside the coil, causing the coil itself to break. Therefore, it is necessary to provide glycol in the plant water. In order to avoid glycolating the entire system, HiRef has developed the glycol-free solution, which involves inserting an additional heat exchangers inside the chiller itself and creating a circuit of free cooling where only in that circuit the use of glycolated water is limited. What does it involve? As we can see in the image on the right, there is an addition of extra heat exchanger and a pump that allows the circulation of water within this circuit. Obviously, this solution brings advantages, namely that we don't have glycol in the system, and therefore we have lower pumping costs throughout the year on the plant side. But we also have a reduction of free cooling hours compared to the standard free cooling solution, since the intermediate heat exchangers requiring a thermal approach reduces the operating hours in this mode. Another aspect to consider with the glycol-free kit solution is the presence of a pump serving the free cooling circuit, which increases electrical consumption and therefore slightly reduces the efficiency of the chiller. Thank you for your attention, and I invite you to follow us on our social channels and activate the YouTube bell so you won't miss our next videos. Ciao!